Good evening, everybody. I'm Sreeram. Pleasure to be here. Thanks to the 7X team for inviting me here, and thanks to you all for staying late in the evening to listen to this talk. So, a brief introduction. I'm Sreeram, founder of EigenLayer. I have been a professor at the University of Washington, Seattle, where I ran the UW Blockchain Research Lab. Today, I'm going to talk about how we can use EigenLayer to augment the Ethereum rollup stack. Awesome. So we know a bit about rollups, right? Rollups augment, move execution off-chain and move computation and memory off-chain. And this is a scaling strategy for Ethereum, but there still remains many roadblocks in order to get layer 2s and rollups to the end state. What are they? The first one is the data bandwidth of Ethereum is very, very low, 83 kilobytes per second. That's the data bandwidth of the entire Ethereum blockchain. If you don't use Ethereum for any computation, just write data to Ethereum. And this is a very important function that rollups do, because rollups still need to publish the inputs or outputs of their computation onto the Ethereum blockchain. The finalization time is very slow, 12 minutes to finality. And finality is very important because if I want to move information from one rollup to another rollup, the rollup needs to finalize on Ethereum. Rollups still rely on single node sequencers, a single node which orders transactions in order to get fast censorship resistance. The bridging experience inside rollups, as well as between Ethereum rollups and outside chains, leaves much to be desired. And finally, how do we utilize the ordering freedom called MEV, or minor extractable value, or maximal extractable value? How do we manage this properly so that users get maximal benefit? So how we view this is EigenLayer provides a comprehensive base layer solution to go and augment the Ethereum roadmap. So any of these problems can then be built on top of Ethereum shared security. How do we get to Ethereum shared security? Ethereum security occurs because stakers stake ETH, deposit it into the Ethereum contracts, and then promise that they will validate Ethereum correctly. What happens with EigenLayer is we enhance the functionality from just staking, where you take your stake and then lock it up onto Ethereum, to now expand it to promise any other protocol building on top, be it an Oracle, data availability, a bridge, MEV management, any of these things. We call these actively validated services. Anything that requires active validation and decentralized service, you basically can build them on top of EigenLayer. What you do is, as a staker, you promise that you not only promise your ETH that you will validate the Ethereum blocks correctly, but you also promise that you validate all these other systems correctly. Otherwise, you may be liable to lose your ETH. So when you're building an AVS, an actively validated service, any one of these things, an Oracle, a bridge, any of these things, what you're building is an off-chain container, which basically lets you run any arbitrary program, and an on-chain contract, which basically does some of the core management, registration, payments, and slashing. So that's what EigenLayer is a system of contracts on Ethereum, but it broadens who the stakers can supply their security to. Instead of only the core protocol, now any other protocol which is restaked can also obtain the security from ETH staking. So what can you do with this? You can actually go and build new modules which then address the problems that I laid out earlier. For example, the data availability problem, you can build a data availability service on EigenLayer, which then solves this problem. We are ourselves building EigenDA, a data availability service, which actually has very high throughput and provides data availability guarantees. You can start building MEV management solutions or super fast settlement solutions where a lot of stake underwrites your settlement guarantees, or decentralized sequencing, or low latency bridging, any of these different kinds of features on top of EigenLayer. It doesn't mean we will build all these things. We won't. We want other people, and we are partnering with a lot of different projects to be building all these different kinds of services on EigenLayer. Okay, so in the next few minutes, what I'll do is give a quick overview of EigenDA, which is our data availability service, and then hint a little bit about what other services are being built on EigenLayer. So when you're thinking about a data availability layer, first I want to lay out what properties do we want from a data availability layer. We want high bandwidth. When I talk about high bandwidth, we call it hyperscale. Hyperscale means if there are n nodes, each of them have a certain bandwidth, you want to be almost as performant as n times c. If each node has c bandwidth. Low cost. You don't want, right now the cost of data availability is every node has to download and store data. This is really, really expensive. In Ethereum, there are 500,000 virtual nodes. So this can become very, very expensive. What you want is actually to be almost similar to one node downloading and storing data. That's what would be low cost. Low latency, it should be very similar to like when you send an AWS query, it goes to the server, comes back 2 times of the round trip latency. You want it to be verifiable. When the system's running, outside nodes should be able to check that the system's working correctly. This is the property that many other data availability systems exclusively focus on. And finally, customizability. Customizability means the data availability layer should be adaptable to different nodes, which want different safety liveness trade-offs, different staking tokens, different kinds of erasure codes, all kinds of different things. EigenDA is a data availability system which achieves all these properties. How does it work? You have the Ethereum restakers who opt into EigenLayer and opt into EigenDA on top of EigenLayer. What do? When a sequencer for a rollup, remember that EigenDA is a data availability service that rollups naturally use. Rollups have a node called a sequencer which orders all the transactions and then writes some state to Ethereum. And when they write the state to Ethereum, what they do in addition now is they create an erasure code using the package that we give them. And this erasure code is built on KZG polynomial cryptography, which is what underpins dank sharding, which is on the Ethereum roadmap. And they take a data blob, and they take this blob and then encode it into many small chunks. Each chunk here in the picture is much smaller than the data blob. And that's precisely how the data is encoded. Each of them send these chunks to each of these nodes. Each node downloads something which is roughly 1/n, if there are n nodes, the size of the whole data. So that's what each node downloads. They sign off on this thing, saying that, yes, I downloaded and received the right chunk. They get a proof that they got the right chunk through the KZG encoding. They send these signatures back to the sequencer. The sequencer aggregates all these signatures and then sends it to the EigenDA contracts on Ethereum. So what's happening is on Ethereum, there is a record that a data corresponding to this data commitment has been stored on EigenDA and certified. And there is an incentive mechanism which keeps the nodes honest. Okay, so that's the high level of how EigenDA works. And I'll give you a little bit of insight into how we designed EigenDA. It's designed to optimize the cost basis of operation. And if you think about the cost basis of a system like EigenDA, there are many contributors to it. So there's capital cost, which is you have to stake. So if you're staking $1 billion, you have to give the users a 10% APR on this $1 billion. That's $100 million. So how do you optimize capital cost? How do you optimize operating cost? Every node has to download and store data. How do we optimize that? How do you optimize congestion cost? Every system today is priced on congestion. If you know Ethereum EIP 1559, the block price increases based on if there is congestion or not. So congestion is a significant cost and an uncertainty to a rollup. If you're a rollup, you don't know what the price is going to be tomorrow because maybe Yuga Labs does a Bored Ape drop, and then now you're congested. Significant problems in the landscape. And EigenDA solves all these problems all at one go. How do we do it? The capital cost is solved by shared security. Restaking, you're using the same stake across many applications. Common stake reduces the capital costs. Operating costs. I explained in the last slide, the data, every node doesn't download and store all the data. Every node downloads a little bit of data. Together, they download all the data. The cost basis is very, very low of operating the system. And finally, to reduce the congestion cost, if you increase the throughput, then you reduce the congestion cost. Not only that, on EigenDA, there is a mechanism to reserve the amount of space that you want. If you're building a rollup, a gaming rollup maybe, you can come and reserve, I need 20 kilobytes per second just for my rollup for the next year. And you pay a much cheaper fee than buying on the spot market, because you're reserving a whole bunch of data. So that's how EigenDA works. It shaves every single cost basis so that we can actually move to an economy where we can start thinking about moving the cloud traffic on-chain. That's the goal that we have for EigenDA. And just to give a quick glimpse of numbers, EigenDA is right now on our private testnet, will be soon on public testnet at 10 megabytes per second. This is much greater than Ethereum right now, and Dangstarting, which is 3 years down in the Ethereum roadmap. And we have a roadmap to scale this another 1000x in the coming 4 years. We are doing this not by adopting the Solana roadmap of actually having each node download and store a lot. We're actually doing this, achieving this high throughput without each node requiring to have a high node bandwidth requirement. So you have very low node requirement, but very high throughput, and a lot of customizability. I'll check the time to make sure. 3 minutes. Okay. So I think what I'll do in the remaining 3 minutes is just point out how EigenLayer can be used for various other things to solve, for example, the sequencing problem. Instead of having one sequencer, we can have many sequencers run through the EigenLayer staking mechanism. Espresso is actually already building a protocol like this on EigenLayer. You can start building fast settlement layer. Instead of waiting for the 12 minutes on Ethereum, or waiting for several hours that Starknet waits today, you can actually write proofs into an EigenLayer service, which verifies your proofs and then certifies that you've done it correctly. You can start building bridges. Many bridges we are in partnerships with, which are building, fast bridges to move data across various layer 2s and layer 3s. You can start building very sophisticated MEV management where you don't have to only do auctions. You can do event-driven actions. You can do partial block auctions. You can do threshold cryptography. You can do block space futures, all of this on EigenLayer. Going back to the starting point, I pointed out many limitations on the Ethereum modular roadmap. Data bandwidth is low. We can solve it by building something like EigenDA. Finalization time is too slow. You can take a fast consensus protocol and throw it on EigenLayer, and you can get super fast finality. You can move from centralized sequencers to decentralized sequencers using EigenLayer. You can build very high quality bridges with very high economic security. And finally, you can build modules for doing sophisticated MEV management on EigenLayer. EigenLayer, I just want to summarize that EigenLayer is a great complement to the modular Ethereum roadmap, where any significant features which are missing from Ethereum can be provided by permissionless innovation. Any of you here coming up with a new idea for how to build this can actually come and patch that particular problem for Ethereum. Our vision is that just like AWS enabled a plethora of software as a service tools to be built, and any end user application then concatenates these SaaS services, EigenLayer enables a decentralized SaaS economy where you can build new decentralized SaaS services, and end user applications can just simply concatenate all of these to build users of on Ethereum. I think with that, I'll conclude this talk. If you're interested, please follow us on our EigenLayer Twitter handle and on our website. Thank you so much to the 7x team for organizing this.
Thank you.